All right, we're finally on the last method. So this is the last method of solving a quadratic equation or finding the zeros of a quadratic function, and that is the quadratic formula. So every quadratic equation can be solved using the quadratic formula. So some people argue, why don't we just teach that? Well, in Math 56, so Math 11 Foundations, that is all they teach. They're like, hey, solve using the quadratic formula. But in Math 50 or Math 11 Pre-Calc, they're like, hey, you know what? There are 4 tools that can do the same job. Your job is to know how to use all of them and then use them for the appropriate situation. So for me, I solve using the quadratic formula when there's nothing else I can do. When I can't factor, when I can't solve algebraically, and when I can't complete the square. So a quadratic equation is in the form ax squared plus bx plus c is equal to 0. The quadratic formula uses the coefficients and the constant and puts it into here, and you get x equals negative b, so the opposite sign of your middle coefficient, plus or minus the square root of that b squared, minus 4 times the a times the c, all divided by 2a. This formula is written on your formula sheet. You are not expected to memorize it. I do recommend writing out this literal formula until you get really used to it. So here I've just put numbers straight into it, but I really do feel strongly that if you write the literal formula first, you make less mistakes inputting your numbers in. So you do you, but that would be my recommendation. But what we're going to do is we're going to practice 2 questions where I've put the numbers in for you, and we're just going to simplify them. And you'll see why I've chosen these 2 questions in a second. So here's my first quadratic equation. So the a value is 6, the b value is -7, and the c value is -3. So you always take the sign with it. Then we've put it into the formula. Negative b plus or minus b squared minus 4 times a times c all over 2a. Now, this isn't usually the part that people struggle with. What people usually struggle with is going from here to here. So the first thing I did was go -7 is +7. I've also done 2 times 6 is 12. And what I want you to do is take this number underneath the square root sign, which we call the discriminant, and I want you to simplify it. So I want you to use your calculator, and I want you to plug in -7 squared minus 4 times 6 times -3, and see if you can get the right number underneath the square root sign. So I'm just going to grab my calculator and make it just a little bit smaller. Okay, so I'm going to put in -7 squared. Now my calculator will make me put brackets. Some of your calculators might put the brackets automatically for you. And then I'm going to take away 4 times 6 times -3, and I end up with 121. Okay, so why did I choose this question? Well, I chose this question because the number underneath the square root sign, which if you've taken any other course, you'd recognize as the discriminant, is a perfect square. And so we can actually take the square root of it and get 7 plus or minus the square root of 121 is 11 all over 12, which means there's going to be 2 answers. One of the answers will be not -7, +7 plus 11 over 12. And the other answer will be 7 minus 11 over 12. If I have 7 plus 11 over 12, that gives me 18 over 12, and that would simplify to 3 over 2. If I have 7 minus 11, that's -4 over 12, which would simplify to 1/3. Now I got these 2 very nice rational answers, which means this question was solvable by factoring. 2 numbers that multiply to give me -18 and add to give me -7 are -9 and 2. If you'd seen to factor in the beginning, would you find that easier? Are you now relieved because you never have to factor again because you can always use the quadratic formula? There's kind of 2 camps. Some people love factoring, some people hate factoring. So just showing you, again, another example where we solved by the quadratic formula, but I could have solved by factoring. All right, what about this one? So for this one, the first thing I did is I just wanted to show you that sometimes the equation aren't written in that standard form first. So this had x squared minus 4x equals 8. So the first thing I have to do to use the quadratic formula is subtract 8 from both sides to get x squared minus 4x minus 8 is equal to 0. Then my a value is 1, My b value is negative 4, and my c value is negative 8. Again, I just want you to practice simplifying the discriminant. So what would I get if I did negative 4 squared minus 4 times 1 times negative 8? Now for me, I actually don't even plug that in like that. If I was doing this question, I would actually plug this in as 4 squared because I don't care about the negative because I know that nothing, when you square it, doesn't matter that it was negative. And then when I see two negatives, I right away plug in plus. So I don't often put in all these signs. I would just do plus 4 times 8. And that's how I would plug it in. But you guys get to decide, whatever makes sense to you. Awesome. Now, if this was a question that wanted approximate solutions, I would stop here. You don't need to simplify. You could plug in 4 plus the square root of 48 equals divided by 2, and 4 minus the square root of 48 equals divided by 2. But this question wanted exact solutions. So what can I do? Well, this is exact, but can I simplify? Is there a greatest, or is there a factor of 48 that is a perfect square? Well, sure is. Square root of 48 could be the square root of 16 times the square root of 3. So this is going to simplify to 4 plus or minus 4 root 3 all over 2. Can I simplify further? Well, yes. There's two ways of thinking about this. This is a binomial being divided by 2. When you think about bedmass, it's like the numerators in a bracket, so you have to add before you divide. Or you could divide both terms by 2. You could do 4 divided by 2 plus or minus 4 root 3 divided by 2. And the key thing there is that you can't just divide this 4 by 2. A lot of people are like, oh yeah, 4 divided by 2, done. I've done the division. Well, no, both of these terms are getting divided by 2. So you have to do 4 divided by 2 and 4 root 3 divided by 2. And then that would simplify to 2 plus or minus 2 root 3. If you don't like that step, instead of doing the each term divided by 2 thing, you could have noticed that there's a greatest common factor of 2 in your numerator. And then you could simplify the 2's, and you're still left with 2 plus or minus 2 root 3. Okay, so now what I want you to do is one from scratch. So I want you to take this question and I want you to solve it by using the quadratic formula. I recommend starting, if you're not used to the quadratic formula yet, I would recommend starting by writing it out, right? Copying it from your formula sheet. It's not something you have to memorize. Okay, so hopefully you've paused the video and you're just coming back to check your answer. I also find it helpful to do that whole thing where you pull out A, B, and C. Just the less mistakes you can prevent yourself from making. Now I go minus minus b, so I would put that in as a plus 4. Plus or minus the square root of negative 4 squared minus 4 times 1 times 6 all over 2 times 1. That's going to give me 4 plus or minus the square root of 16 minus 24. Negative 8. Then, can I simplify this? So I've got 4 plus or minus the square root of 4 times the square root of 2 times the square root of negative 1 all over 2, which is going to give me 4 plus or minus 2 root 2i all over 2. So this is my first time I'm getting imaginary answers in a while. Now, can I simplify this? Yep. I could divide both of those terms by 2 and get 2 plus or minus root 2i. Or you could think of it as greatest common factor of 2 out of the front or out of the top, and then you can simplify the 2's. But this would be my final answer. Just know that all the questions, like these ones, oh, we haven't had one in a while. Maybe back here. These ones where we had this or idea? Remember how we were like, oh, it could be like this or this? When you have an imaginary number, they always want to write it as a plus or minus bi. So they will actually never write it as a single fraction. So if you had an answer like 3, that's a bad example. Let's say 8 plus or minus the square root of 3i all over 3. if they had something like that, they won't actually leave it as a fraction like that. They would actually write it as 8/3 plus or minus the square root of 3i. So they're very particular. This textbook is so, a lot of these textbooks lately are just very precise, which is awesome. And so just know that if you get in this habit of writing everything like you would from a quadratic formula, they break it when there's a complex answer. They go straight back to that a plus or minus bi idea, and they would write it like, sorry, I forgot the divided by 3 there. They would write it like that. So just heads up, things that the textbook does, in case you're wondering why it does it, that is one of them. Awesome. Good luck.